Hi, this is extension 4.2, and we're just going to be talking about slopes of parallel and perpendicular lines. So there's something special about the slopes for each of these types of lines. So just to review, remember a parallel line is a set of lines that are never going to intersect. I always think of railroad tracks. They're straight and they're never going to touch each other. They're never going to intersect with each other. So those are parallel lines. And the graph right here also has a example of a parallel line. Non-vertical parallel lines have the same slope. That's how you know if they're parallel. Okay, non-vertical parallel lines have the same slope. So all vertical lines are parallel. So remember, vertical straight up and down, and horizontal straight across. Those are parallel as well. So let's go ahead and take a look. Identify parallel lines. Which two lines are parallel? How do you know? So the blue line here, they use y2 minus y1 over x2 minus x1. And you can certainly do that because they give you 2 points on the line. They give you -4, -2, and -3, 2. However, I like to just count from dot to dot and use it that way. So if I always start at my lower point, remember you can count up and over. So 1, 2, 3, 4 over 1. So that would be 4, which is what they have right here. The red line, I'm going to start at the bottom, count up 1, 2, 3, 4, 5, and over 1. So it would be 5 over 1 or 5, which is right here. And the green line, again, start at the bottom, 1, 2, 3, 4 over 1. 4 over 1 is 4. And that's what they have right here. Again, you can use the y2 minus y1, but if they give you the graph, I feel it's easier just to count. So you can do it whichever way you'd like. Since the blue line has a slope of 4 and the green line has a slope of 4, those two lines are parallel. Okay, so stop the video right now and I want you to try to do numbers 1 and 2. Okay, we're going to go ahead and check and see how you did on numbers 1 and 2. So the blue line, I'm going to go ahead and start at the lower one. I'm going to count up 1, 2, 3, and I'm going to count to the left 1. So remember that when you count up, that's a positive number, and when you count to the left, that's a negative. So that would be a +3 over a -1. So actually that would be a slope of -3. The red here is up 1, 2, 3, and over 1. So +3 over -1. So again, that would be a -3. Sorry, my writing's weird with the mouse, but I hope you can read that. And then the green line, same thing. Up 1, 2, 3, 4, over to the left 1. So +4 over -1 would be -4. So parallel lines have the same slope. So my blue and my red are parallel. How do I know? Because they have the same slope. All right, let's check out number 2. I'm going to start with the bottom, 1, 2, 3, 4, 5, 1, 2, 3. So up 5 to the right 3, that would be 5/3. If you wrote 1 2/3, that's fine. I'm just going to leave mine as 5/3. The red line, 1, 2, 3, 4 over 1, 2, 3. So that would be 4 over 3. And the green line, 1, 2, 3, 4 over 1, 2, 3. That would also be 4 over 3. So my two parallel lines are the red and the green because they have the same slope. Okay, if you're looking down at these equations down here, if you can kind of just visualize the graph, the first equation, y equals -5, that's going to be a horizontal line at -5, and it's going to be about right here. And the second equation is y equals 3, and that's going to be up here. So you can see that those are two horizontal lines, and so they are going to be parallel. Both of those slopes are going to be 0, so they have the same slope. So yes, sorry, that's bad handwriting. Slope is 0. All right, if you look at number 4, here's my graph. Y equals 0. Again, that's going to be a horizontal line, actually right on the x-axis right here. And then x equals 0. Well, that's my y-axis right here. So look how those intersect. I'm going to redo that because that was kind of bad. Those intersect. So those actually are perpendicular. They're not parallel. So I'm going to go ahead and say no. They're perpendicular. You can put that they're perpendicular or that they intersect. All right. Intersect. All right. Last one. X equals -4. So that's going to be a vertical line at -4. Woo. X equals 1 is a vertical line at 1. Those are parallel. Yes, because their slopes are both undefined. And they told us back here, actually, all vertical lines are parallel. So if you're looking at the equation, if they both are y equals or they're both x equals, they're going to be parallel. If there's one of each, it's going to not be parallel. All right, awesome. Now we're going to move on to perpendicular. So a perpendicular line, a set of perpendicular lines is when they intersect at a 90-degree angle. See here, they form a right angle. That's 90 degrees. Okay. It says two non-vertical lines are perpendicular when the product of their slopes is -1. So that means when you multiply their slopes together, it equals a -1. Another way that I think about it is if you have a slope, let's say, of 2/5. If the lines are perpendicular, the other slope is going to be the reciprocal of it and the opposite sign. I call it the negative reciprocal, or you could call it the opposite reciprocal. So you just flip it and there should be a negative. Or if this was negative, you flip it and it should be a positive. And that's how you can tell. All right, so let's do an example, or let's look at an example here. So the blue line, if you count, if you go down 2 over 6, down is a negative movement, to the right is a positive. So it'd be -2 over 6, and you can reduce that to -1/3. The red line is down 2 over 7, so it'll be -2 over 7. And then the green line, you start here, you count up 7 and over 2, so that would be 7 over 2. So if you see here, -2/7, flip it and change the sign, you get 7/2. So you know that those are perpendicular. Okay, let's go ahead and let's do number 7 here together. And then we can go ahead and I'll have you stop the video and try number 8. Okay, so let's look at the blue line. The blue line is the slope 1, 2, 3, 4, 5, 6 over 1. So it would be 6 over 1. I'm just going to write B for maybe write B. B for blue. So it would be 6 over 1. And then the red, if I was really good, I'd probably use red ink, but I'm not. 1, 2, 3, 4, 5 over 1. So this would be 5 over 1. And the green is down 1 over 1, 2, 3, 4, 5, 6. So down would be -1 over 6. So if I'm looking, I see 6 over 1. I flip it, I get 1 over 6, and it's the other sign. It's a negative. So I know that blue and green are perpendicular. And when it says, how do you know? You can say it's the negative reciprocal or the opposite reciprocal, or you could say that when you multiply the slopes together, you get -1. So if I take 6/1 times, I got that there, times -1/6. So 6 times -1 is -6. 1 times 6 is 6. -6 divided by 6 is -1. And when you have perpendicular slopes, you should, when you multiply their slopes together, you should always get -1. Okay? All right, stop the video and you try number 8. All right, welcome back. Let's check it out. The blue is going to be down 2/4, -2/4, or -1/2. The red is down 2/4, -1/2. That's interesting. And then the green is going to be up 6/3. So 6/3, which is 6 divided by 3 would be 2. And remember, when you have a whole number, if you write it as a fraction, it's over 1, right? So I have -1/2. If I flip it, it's 2/1. Opposite sign would be +2. So actually we have blue and green that are perpendicular, but we also have red and green that are perpendicular. So blue and red are parallel, so they're both perpendicular to green. So we have 2 sets. And again, how do you know? You can go ahead and just say that when you multiply the slopes together, you get -1, or you can say they're the opposite, the opposite reciprocal of that. All right. And so then when you're looking at equations, same thing. If you have the 2 x's or 2 y's, it's going to be parallel. So this would be a no. If you have 1 x, 1 y, those are perpendicular. So you can say yes. Okay. And that's it. We do have a math book or a worksheet assignment with this, but Caitlin, I'm going to go ahead and say that you do not have to do that. Okay, just watch this video and that will be good enough. All right, thanks, bye.